Hello, calculus fans. Let's talk about one-sided limits. Now, in our previous example, we talked about the Heaviside function, which looks like this guy. H of t is equal to 0 if t is less than 0, and it's 1 if t is bigger than or equal to 0. Let's look at a graph. All right, this is the graph that we looked at in the last video. We noted that h of t approaches 0 as t approaches 0 from the left, that is, when we're going through negative numbers. We also noted that h of t approaches 1 as t approaches 0 from the right, that is, through positive numbers. And we also talked about this means that the limit does not exist. However, we can say the following. The limit as t approaches 0 from the negative side of h of t is 0, and the limit as t approaches 0 from the positive side of h of t is equal to 1. So when we write down the symbol t approaches 0 from the left, means that we're only considering values of t that are less than 0. And then the symbol t approaches 0 from the right, so this minus sign and this plus sign, we'll call that approaching from the left and approaching from the right. That means we only consider values of t that are bigger than 0 now. So let's make a definition. What we're going to do is we're going to say that the limit as x approaches a from the left of f of x is equal to L, and we'll call this the left-hand limit, or the limit of f of x as x approaches a from the left. This is equal to L if we can make the values of f of x arbitrarily close to L by taking x to be sufficiently close to a, and x has to be less than a. So we're not going to consider values of x that are bigger than a. Now the original limit is what we're now going to call a two-sided limit. That's where we have to consider values of x that are less than a and bigger than a. So in a two-sided limit, we allow values of x close to a and possibly on either side of a. Now the definition of the one-sided limit, it's only slightly different from the definition of the two-sided limit. For our one-sided limit, we're requiring x to be less than a. Now we can make a similar definition for a right-hand limit by making some obvious changes. And now we'll write limit of f of x as x approaches a from the right, and this time we require that x to be bigger than a. Okay, that's all for now.